Okay, thanks. Hi, I'm Mike Morley from Arcurve, and this is my colleague Pete Tunkis, also from Arcurve.
Howdy.
And we're here today to talk to you about a subject that we've been thinking about for quite a while that's super interesting. And it's this idea that we're calling the time mine. And our sort of little tagline here is, what do an underground mine and a consulting firm have in common? So Arcurve is about a 220 person consulting firm that has offices across Canada and into the United States. So, and many of the consulting firms that I've worked in, Arcurve included, it's a really interesting challenge around trying to model and understand capacity and then make forecasts about availability and capacity in the context of, you've got a whole bunch of really smart people, they've got a bunch of experience and skills, they develop and improve or increase their experience as they work on projects. And it's really fascinating because even though I've worked in this industry for quite a while, I've never actually seen a super effective means of modeling and particularly in the context of projecting forward-looking or forecasting capacity. And it's because it's a fairly complicated challenge. You've got quite a number of different variables that factor into a person's capacity, vacations, the type of work that they do, what projects they're allocated to. And of course, anybody who works in this discipline or this domain knows that projects are something that are quite dynamic. They change all the time. And you have new projects coming in at different points in time. And they may start and stop and move capacity up and down. So it can be quite difficult to put together a team, particularly when you're trying to figure that out in the future. The interesting thing about—
Mike, real quick, can you please put your presentation full screen? Thank you. Awesome. Thank you very much.
You're welcome. So the interesting thing about this, though, from our perspective, my perspective in particular, is I spent a number of years also working in the mining industry. And there's some fascinating kind of adjacent challenges that exist in this domain where you've got a fairly complex natural substance called ore. And ore is it's quite complicated. So this is a chunk of actual ore. This is volcanogenic massive sulfide from a mine called the Winston Lake mine in northern Canada that I worked at for a while. And this chunk of ore was given to me by the geologist there. And kind of the silvery stuff you see disseminated to the rock, that's chalcopyrite. That's sphalerite. So that's a sulfide form of zinc. And the darker stuff there is chalcopyrite, which is copper. And you can see it's all kind of smushed up in this rock. So the model that you see down on this side of the screen here, that's actually a model I constructed the Winston Lake mine. If there's any folks from the Winston Lake mine out there on the call, I've heard a few of them might be dropping in, so that's kind of neat. Hi. The red stuff that you see there, that's actually the ore. So that's the whole thing, that the entire volume of ore that existed or that was delimited by drilling boreholes into it underground. The other bits that you see kind of running around there that are the little this area over here, the purple and the cyan and the brown stuff, those are underground workings. So in order to get at the ore, you got to dig a bunch of tunnels and stuff to get down there. That's considered to be waste. So the goal here, as it is in any sort of mining operation, is to maximize the amount of ore that you're extracting while minimizing the amount of waste that you're having to extract to get to the ore. The other thing that factors into this world too, which I'm just going to bring up a little gizmo here. This is a tool called Geoscience Analyst, and it's used in the world of geology to model complex ore bodies. And what you're looking at here is this is a three-dimensional volumetric block model that represents a mine up in Flin Flon, which I also worked at back in the day. And what you do to model this stuff is you basically go in and you create little blocks of material. And inside of each block of material, you assign a percentage value to that block, which you can kind of see here. So the red stuff is the good stuff. The green stuff is the stuff you want to try and not dig out as much as possible. If we kind of take that away and fade it out, what you're left with is a three-dimensional model of the actual envelope of the material that you want to extract. The other thing that factors into this, of course, is pricing. So there's a lot of forecasting that's done in this domain as well, where you take these block models and you put them against pricing of metals on the market to figure out what sequence. That's one factor that plays into mining, but not the only one, certainly. To figure out, we want to try and maximize the high value material that you're extracting with respect to the market pricing and that kind of thing. So when we're thinking about all this, back to presentation land, really what we want to do is we want to try and construct a capacity model using some of the concepts that we learned in the mining industry. And so to do this, what we is we sort of thought, okay, well, you've got this idea of an employee, you've got their skills, and then you've got their capacity. These are the three constituents of what we would call a timeline. In the context of employees, you get the teams that they're on, you get the places that they work, the responsibilities they currently have, and the reporting accountabilities, that kind of stuff. You have the skills that people have, which can be coming in from education, could be coming in from other types of experience. What have they worked on? So as you're kind of working, being able to track the time that people spend on different projects and activities and whatnot. What types of things do they have the authorization or approval or the right qualifications to do? And then what's their capacity? Are they off on vacation? How many other projects are they allocated to? What's their percent allocation over time? What's the confidence that we've got the allocations assigned to the various projects coming in from the CRM system and things like that? So typically what we see in the world of project management, or so in HR systems, so this is kind of typically where the skills and the teams and that sort of thing live. The other place that's important for data lives is inside of these project control systems. So this is the type of thing where if you're doing timesheets and stuff, you're typing in, I worked on this thing at this time for this much time, and I was doing these activities. So usually a comment that's put in. And pretty much all the systems I've ever seen that do this kind of tracking use a hierarchical structure called a work breakdown structure, project, phase, task, time entry. And of course, that's great for simplicity, but it doesn't actually represent reality all that well. Reality is a lot more complex. So it ends up, you're working on a whole bunch of different projects in the same day. So the last few days, I've actually worked on 3 different projects, including this presentation. I've got my skills, my domain expertise. I've got the different roles that I play in the organization. I have my experience and so on. So what we realized when we were looking at this is that one, the capacity modeling and whatnot, how much time I have available to allocate to activities is pretty complicated. 2, it actually is a heck of a lot. It's a wonderful graphy problem. So Neo4j, fantastic way of being able to construct a model of this sort of reality. And then thinking about it's like, if we think about capacity in the same way that we think about ore, so ore being the stuff that you want to extract. So this is the billable work that's out there that you want to be able to maximize. And then the administrative work, which you still need to do to run the company. You still have to have people get training. They still have to go to meetings. They have to figure out, business development, how to pitch and do statements of work, that kind of thing. So it's essential, but you don't want to you want to make sure you're maximizing your valuable work time while minimizing the amount of admin time that you're spending. You also then want to be able to do things like project forward, and if a person's busy or something like that, you want to be able to bring the skills and those sorts of things into the equation. So this is where I'm going to hand it over to Pete.
Right on. Okay, cool. Actually, sorry, could we go back to the slides really quick, and I'll let you know when I'm ready to display the demo bit. Anyway, so a little bit of a soft transition there into what we're going to be demoing first here, but I kind of want to go over again the sort of this 3 aspects of skills, because if we kind of think about what consulting firms are looking at in terms of their initial stages of project management and staffing and that kind of thing, is that, when a project comes in, the statement of work gets drafted and, project charters get put together and so on. But at the end of the day, right, that leaves you with a list of things that need to be done. And so that'll involve everything from, we need somebody who can do stuff in AWS. And we need somebody who can do stuff in Neo4j or whatever the case may be, using, data sciencey things in Python, or, dashboards in Tableau or NeoDash, or, whatever the case may be, right? And so there are a number of ways to do this, right? And so, so Mike was referring to some of the traditional approaches, and oftentimes something that we really commonly see is let's say data that's collected in terms of timesheets, right? Or you might have data that comes in that you can put together based on Jira boards, Kanban boards, that kind of thing that are shared, like DevOps boards, that kind of thing, right? And so yeah, all that to say that there are generally three ways that you can approach skills. Also because skills are kind of central to all of this, right? When you're determining who's going to be working on what. So one way to do it is prima facie. You could look at experience based on resumes, but sometimes resumes don't always give a full picture of the breadth or even certainly the depth of someone's experience. But it's a starting point. In terms of the activities, so again, derived from project work, timesheets, right? Again, there's a host of different software platforms that are used by HR groups and that sort of thing, is to keep an eye on what people are working on, so that they can bill clients and so on and so forth. And that's in fact what we ended up using. So spoiler alert, we used some Kaggle data, but I'll go into that in just a minute. And then finally, depending on capacity and resources for the HR team, right? Another alternative is to also take into account people's actual like skill level and comfort level with those skills, right? And so we have an example here of this 1 to 4. It's a fairly typical or common type of rating system that's used in the martial arts, for example, right? So with respect to, number 1, you're an expert and you can actually teach the concept, right? All the way down to level 4, which is, hey, I'm new to the company, I'm new to Graph, and I want to learn more about Neo4j. Are there any projects that I could shadow on or something like that, right? Next slide, please. So given that we're taking a sort of an activity skills based approach, so just based on what folks have put into their timesheets and that kind of thing, then there are a couple of questions that we kind of focused on in terms of kind of what drove our passion for this time mine concept, right? Because it's kind of a weird analogy, but it actually does make a lot of sense, right? So some of the more proximate questions that I think are faced by a lot of service delivery groups, HR, and just as a side note, maybe if you're in a big industry, a big enterprise or something like that, what does consulting firm behavior have to do with me? Well, I mean, if you have a lot of people and you have a lot of projects coming in internally, like it's a similar issue potentially, right? Your graph might be smaller if you're in a narrow vertical, but anyway, point is though, is that the fundamental questions are, given a project and given a set of requirements, so the kinds of tasks and things that are going to be there, and let's say we need people who are senior and they have to be available, who are the right people for the job, right? And then the second sort of follow-up is that, okay, so you're a small firm and you have maybe like 10 people, 20 or so, and then that Pete Tunkis is the graph guy. We can go to him for graph. Cool. But what happens in a larger setting when Pete the graph guy is unavailable because Pete's on like 2 or 3 other projects or whatever the case may be, right? Or Pete's on vacation or who knows, right? The capacity just isn't there. So how do we know that if we had to pick somebody from the company, we don't know everybody's skill sets at, like the back of our hands, perhaps. So how do we find out who the right person for the job is? And then finally, an extension to all of this is that, the first 2 questions kind of take an aggregated or perhaps a simple approach, if you will, that I'll walk through shortly. But, if we have all this information about, projects and people on those projects and the stuff they've been working on in the past, then we can also utilize that information to model prospective capacity given whatever number of projects that are coming down the pipeline. And we might have some vague idea that, there's this big project with, a mining company. So we know that they're using these particular data platforms and in conversations, we know that they're going to want like dashboards and other analytics and various things of that nature, right? So even if you don't know exactly what's needed, you can start to kind of plan ahead of the game so that that when the time comes, contract signed, we got to get started, you're ready to go. So anyway, but let's get started with those first 2 questions then. So slide, please. Right. So I like to just call it the people finder, right? Because ultimately, at the end of the day, we're looking for the right people for the job. So the first step, just in terms of what's been done in the background and in part what's going to be shown to you today, is obviously you want to prep the data for the graph. In our case, we used publicly or freely available Kaggle data set. It's like time viz, I think it's called, like visualizing people's time. And we did a bit of tinkering just to add names and things like this, but all that to say, we just wanted to create like a basic proof of concept example there. And once you have those data, then you want to start to integrate the time data, aggregate project history, skill sets across people into a graph. Sort of an assumption too is that, obviously when we have real life data, especially with timesheets, then most of the time it's like low context text, so to say, right? Meaning that you're not going to get complete sentences, and sometimes extracting and cleaning up that text is going to be difficult. So we're just assuming here that the NLP grunt work has been done, but it is a necessary evil for better or for worse. But once you have that all together, then you get that in the graph. Cool. And that's where we have our first little step here in the top right. The next piece is in order to build the people finder, we want to be able to project people, skills, and their experience into memory, right? Graph projection, pretty straightforward there. But indeed, what we're interested in is if we're particularly concerned with the types of skills or tasks that must be completed, and we don't have the people front and center in our minds ready, we need to find people who have similar skill sets, right? And so that's kind of the fundamental basis of it. Obviously, if you have other pieces of data and information, right, you can bring that in for, topological analysis and, additional properties and things like this. But again, just kind of keeping it simple. Because in terms of the projection, right, the first thing we can do in order to facilitate what will basically be a k-nearest neighbors example in this case, but the people finder itself, right? We have to calculate those similarities between people. So we take that employee has experience task topology, and we embed it into a machine readable multi-dimensional vector property. And I'll show you how that's done and what that looks like more or less in just a few. And then the final step is once you have all your embedded properties and everything's good to go, then we can calculate similarities between employees based on things like their roles, their level of seniority, bipartite topology, which indeed relates their levels of experience as well as the skills to which each employee has experience. Slide, please. So I'm going to jump in just a sec, but just want to reiterate what I'll be kind of showing here ultimately is that there are two main kind of things that we can use that I think is really awesome about the power of graph and being able to leverage that approach to analyzing these kinds of data over traditional tabular or relational forms that can sometimes get messy and complex, right? But anyway, first example is going to be, okay, well, I picked a BA, a business analyst in our data set, and we need to find someone who's the closest to our star BA in terms of their skill set and who has sufficient capacity. And I think it's like 80% or something as I set the threshold. And the second example is something that I think also is faced, especially among larger consulting firms. And indeed, if we're going to be looking at prospective team building and project planning, then, maybe we don't want to, start to pick through by hand. Oh, we want this analyst. Maybe we just have information about the projects that people have worked on, the skills that they have, their levels of seniority, their roles, and all that good stuff. Then we can just see, okay, given these sets of requirements, let me condition a search. I want all these people to be kind of related and similar to one another based on their skill sets. So there's, sometimes you have to wear many hats as a consultant, right? That kind of thing.
Or toques.
Or toques in our case. Fair point, sir. But yeah, I mean, you guys, I'm sure you get the idea that, one of the really neat things that we can do here is we can sort of auto-generate team rosters, right? And whether that's the whole team or perhaps you can have like a short list to pick out prospectively rather than, again, going through your entire employee roster and trying to figure out people's capacities and all the rest of it. So Trevor, if you wouldn't mind switching the screen to my side. Perfect. Excellent. So we saw this little graph schema on one of the prior slides. And really the idea here is that Everything in the terms of this little demo here is employee centric, but we have information in our graph that's been aggregated and summarized to, okay, individual employees have worked on particular projects. They have experience in a set of unique tasks. They're related under practices like data or UI, UX, things like this. And of course, there's their role. Are they a data analyst, data scientist, BA, UX, UI, front-end dev, et cetera, right? And so once we have all this, right, we have to go ahead and project the graph. Now, I've already done that in the background because it takes like a couple seconds, and dead time is bad time, I suppose. So we project the thing, and it's in there, right? It's there. And so the first thing that I had mentioned is that in terms of the step-by-step process, is that, once we have the projection stored in memory, then we can start doing our embedding and some of our prep work before we actually run k-nearest neighbors to generate our people finder, recommender engine, that kind of thing, right? And so in this case, I'm using FastRP because it's great and it's fast. And very good at scale as well. Now, I have a couple of arbitrary figures here. I've commented out some of these parameters as, the defaults are fine for the purpose of a demonstration. But in real life, there are a number of different ways in order to optimize these. So, I picked 68 dimensions just because it's arbitrary. But, I think we can be pretty certain that most of these dimensions are not independent of one another. So, whether you're using Optuna, which I know that, CJ Sullivan and Zach Blumenfeld have, put out various articles on Medium or toward data science, that kind of thing, that kind of walk through some of those processes. Or you can use whatever dimension reduction tool you like, right? But anyway, point is that these should be optimized in real life based on the data that you're working with. But yeah, so I basically embed the topology of the graph and weighted by people's experience in specific tasks, make it deterministic for replication, and takes just a moment. And all of a sudden we have, a handful of analysts here with their embedded property now, and so on. Now, with embedding with this, the query I have here is pretty simple. So you'll see there are all these nulls. Well, these are actually the task nodes that were in the bipartite projection, but we can ignore these because ultimately we're only going to be building the people finder on, the people. So this is what matters here. But nonetheless, again, just kind of showing off the point. So next step is we mutate the property onto our projected nodes, which I've already done in the background. And so just to kind of show what the KNN looks like, in this case, I would argue that the code is fairly simple in that, again, I have a couple of things that are arbitrary here, and there are a couple of things that are set for replication or determinism. You can work with and optimize some of these things. Again, this is all data dependent. So our data set is super simple. So, taking a few things for granted here, but you get the idea. So when we run this, just to stream it, then we can see that, well, look, we have information about Dustin Castillo is similar to Megan Gonzalez. As they're both business analysts, no surprise there, super strong similarity, right? And as we go down the list, eventually we're going to hit a point at which, if we look at a complete comparison across, right, in the query, right, I have specified that I'm only looking at employees who have the same role. But if I were to blank this little piece out here and rerun, right? Okay, well, that disappeared. Hang on one sec. And then there we go. Okay, there it is. All right, good. Yeah, so you'll see there's 1640 records. So right, we're at this point, we're now comparing, if we go down to the bottom here, we're comparing data analysts to business analysts, and there's some similarity in terms of their breadth of skills due to the topology that's been embedded, but really they have different roles and perhaps different levels of seniority. So you'll have a variation in terms of your similarity. So after we do all this good stuff, then we want to write the similar to property into our graph, which I've already done. And now for the good stuff, right? So let's say we have a particular employee that we know is going to be like the top-notch star for this new project that's coming in. Happens to be this person, Brendan Park, right? They are a BA. just knowing just a priori, but yeah, they're a BA. And so what we need though is somebody who's like Brendan Park, right? So they have to be similar to this person. They have to have enough availability, and they have to have a shared set of tasks, meaning stuff that they've done, their skills, that kind of thing. And this is it's a very simple query, but it's something that's really helped a lot by virtue of just traversing the graph. And so what we ended up getting here is, given that we have this similar to relationship, we can see that Brendan Park is most closely similar to Caitlin Schaffer, and Caitlin happens to have 85, 86% capacity. So, hey, this might be a great choice. So we can approach Caitlin. And as a backup, perhaps Adam Poole or Sean Reynolds, so on and so forth. You get the idea. Right. And so in this case, I have it ranked by similarity, but you can also rank by availability as needed in your front end and, for the dashboard or the app or what have you. But next is similar to this particular case here. Now, this next query, I'm not going to be using the recommendation engine or the people finder, as I like to call it, per se. But again, this is something that Graph does that, let's say, an Excel spreadsheet or something like that doesn't, right? And that is just making some of these searches really easy. And again, especially at scale, when you may be dealing with a very large number of people, not just 40 or 41 in our case, or perhaps it's thousands if you're a multinational consulting firm, right? So in this case, what we're looking for is somebody who has prep, refers to data prep. It was like truncated, but it is what it is. But yeah, we need somebody who can do data prep and that they have availability of at least 70%, right? And so again, this is nothing very complex, but a search reveals that our best person, in terms of being like an epic rock star, 35 hours, on average, for this particular data analyst, Derek Smith. Rock on, we found our person, and they happen to have more than 70% availability. Looks like we found our person. But again, the question is, what if Derek is not available? And moreover, if we know what our prospective skills and tasks and what the project is going to be all about, we don't necessarily, again, want to be searching for each individual person based on an individual task or anything like this. So what's the answer? Well, there's two, right? One, we can obviously, broaden our query and the scope of it, right? So that we're covering more skills. But let's say we also want to make sure that, those people that we have in our prospect list, they've worked together on a few projects perhaps, and again, that they have these sort of similar skill sets to one another, right? Just in terms of the breadth, not just necessarily the depth. And so to kind of demonstrate what that looks like in terms of a graph traversal per se, is that in this query here, what I'm looking at is, well, first, again, we need somebody who's, we need pairs of folks who have been working on at least 2 projects together in the past. And we need both of them to be available 70%. And so we take that information and, hey, well, we also want to make sure that they are similar to one another, as I mentioned. And we want to make sure that they're sufficiently similar to one another. And I can just kind of set similarity of 0.7, but that's optional. You can set whatever you want. And then finally, we also want to make sure that each one of our resultant employees from our search has experience in particular tasks. And in this case, for data, there's, doing EDA, putting together metrics, data prep. For our UI, UX friends, there's some design that has to be done for the front end. And we need a few BAs to do things like charts and put together the slides for presentations. Oh, and we also happen to need a full stack dev who can at least do Angular, right? Which, to help tie all these things, some of these things together. And so when we run this particular query on our little employee and task graph, we end up with a pretty succinct set of results once it maximizes here, maybe, kinda. Maybe not. Oh, you know what? Okay, well, anyway, you get the idea that essentially what we have is we have our different tasks. So here's prep, EDA, metrics. I know it's really hard to see. I can zoom in some. And as it turns out, we have a few people who have shown up in our search, right? So we have a couple of data scientists, data analysts. Over here, we have a full stack developer. Down here, we have our BAs, and so, this is just a nice way to kind of visualize what this looks like in terms of how the graph is traversed in order to find and generate our results. But of course, the real bacon at the end of the day is going to be, well, look, we need that list. We just need the people. Nodes and edges are cool, but yeah, we need results. And indeed, here they are, right? So we have our short list of business analysts and their availability, as well as their collected skills coverages, right? So we can see who's kind of got cross skills here. So maybe Kevin and Adam are going to be our best choices if we needed to. And then for our analysts and data scientists, right, maybe we'll want to bring in Brian Stewart and again, Derek Smith, because he's a bit of a superstar. Hey, so we have lots of different options, and again, this could either generate your whole team roster for you right off the bat, or at the very least provide you with a short list from which you can select your eventual team members and talk with them. Is this something you want to do, et cetera, et cetera. So lots of heuristic tools that kind of hopefully make the job easier. And so with that, I'm going to hand over the mic to Mike, and he's going to take all of this one step further and show how we can look at those prospective capacities across our little consulting firm.
Cool, thanks. Thanks, Pete.
Yes.
Yeah, so I will attempt to tie this back into the mining aspect and the block modeling capacity. So Pete talked about the skills and the way we hook people up and that kind of thing. So the other piece of the equation then is how do we set up a model that allows us to give ourselves a foundation to be able to look forward in time, to take the kind of the projects that are out there and then connect them back to people, so that then we can do things like show me all the people who, as Pete had demonstrated, who have these sorts of skills, who may be similar to other folks, and then get a sense of their actual capacity in the future. So what we're going to do is we're going to think about modeling of topology of resources being equivalent in some way to ore modeling an ore body. So when we think about it, what we want to do is the ore is the billable time, and the project work essentially denotes different types of ore, and the admin time denotes mine workings. So what we want to do is we want to create a graph for each person's availability, and we use a time tree to do that, of days and hours. Each individual time tree graph represents effectively one type of time in this thing. Then we set various different types of targets for people, and then we can also apply factors like full-time equivalency. So if a person is only working part-time or something, you can then add that factor into your timeline time tree graph. And then we can do things like derive vacations from calendars that are out there. So you can mine things like Exchange and stuff like that. You can mine the CRM system to see what projects are coming down the pipe and what the probable the likelihood of that project going forward is. And then we can also do things, I think, as Pete had mentioned, is we can use the historical data to also provide a bit of an idea of, or inform the graph, the capacity model looking forward. You can do some statistical analyses to say, hey, these sorts of folks and these sorts of projects have these types of potential capacity models associated with them. So it kind of looks a little bit like this. You've got the skills graph foundation. You've then got the data that comes in from the experience and work. So this is taking your HR system and your project control breakdown structure system, and you're using that as the foundation to then construct this capacity model. And the capacity model looks a little bit like this. So then the way we see it working is you basically have now, and then we set this up inside of the toy data set. So we picked kind of a demarcation. I use day index 318, which is 22, 11, 14. And then we have the past. So then you have the work that people did, billable, non-billable time, that gets projected down to a time, a linked list time tree thing that's hooked up to each employee. You fill in this capacity node by kind of pulling all the time off the projects and the work that people did. You drop it onto the nodes on this chain, and then we generate that chain going forward for every single employee. And then we hook that up to the various forecasted projects to make a bit of a forward-looking projection. Then we can have fun with it and do things like, hey, you've got graph XR. which is a great tool for doing this sort of thing. You can basically project by assigning Cartesian, thinking of time as Cartesian coordinates. So in here, basically what you've got is you've got your days going up the one axis as being points in time. You've got your months of days at the x-axis here, as you can see on the bottom. You have months going up the axis here, and then you have the employees on the other axis. And then what I've done is I've scaled the nodes in this case by the amount of available capacity that the person has. And so bigger nodes means person has more capacity available. And then I've colored them by the type of experience the person has. So by doing this, you can kind of get a sense of this is actually what a block model looks like. In this case, we're using nodes instead of blocks, but it's the same idea. So that provides kind of a really nice little visualization that you can move around in. Then the other way you can do it, of course, is you can if you're more not a person who's versed in mining engineer or whatever, mining engineering, you can use this wonderful tool, and I love this thing, NODES. You basically can set this thing up so you type in a person's name, like Kevin Campbell. You can see a little chart using Pete's similarity model to figure out who this person has worked with and who they're similar to. So this is basically an enumeration of the shared coincident work that people have done on this in the past. That becomes a feature in terms of the similarity model. That can then be put into this type of a visualization where you basically put your date range in, say, okay, my project is going to go from this date to this date in the future. I want to pull out resources. I need somebody, people who are versed in modeling, development, testing, UI. This is my team analysis. It'll go through and then it figures out, it looks at the capacity model, it's here. And then you can project that into a sort of a chart kind of a thing to say, hey, well, here's when these folks are available. And then you can factor Pete's similarity model into that and say, hey, if we don't have any folks available in the design side of things, we can then look for other people who may be similar to Deborah Bradford, for example. You can also do cool little radar chart things with this where you go, okay, well, I'm good on the design side. I got lots of people available there. But I'm pretty skint on the engineering side. So I got to try and find some other alternate engineers for this, and probably also some data analysts. So although I'm a little better on that front. But if we really want to get fancy with this thing, what we might want to do is go back to our friend, geoscience analyst, pull this guy up. So what I did here is I projected that same 2-week period into the geoscience analyst, making it think it's an actual ore body block model. And this is fully 3D, blah, blah, blah. So you can see there's the entire time domain is actually that big kind of structure that you see here. This is the 2-week period associated with the dimensions that I selected. This particular team I pulled out of a similarity analysis. Then what you can do is you can do things like, I'm gonna blend the colors of the availability. So the availability curve is down here. So this is available time. And I'm going to scale or shade that by expertise. Then you can do fun things like, I practiced this and now I'm totally missing it. If I hit my X key and I want to put a slice through this, let's slice time. Ooh, cool. So you can actually put a slice through the time in sort of any direction. So if I want to kind of see, if I want to have a look at a particular, through a particular time domain or whatever, I can actually slice this block model. You can create a section of time. So whether you're doing that by days, by experience, by skills, by whatever dimension you publish into this thing, because these blocks are not limited in dimensions. That right now I've only put in capacity, expertise, ore, and waste. So basically saying my allocations associated with known capacity in the future for actual project work. And then the other number is the amount of time a person's been allocated for non-project work. But I could also put in here things like actual projects that they're allocated to, the history of the work that they've done, and you can actually get this model to be fairly involved in terms of the different number of dimensions, and then you're able to slice this particular model in any way that you want. This is kind of the power that you have with respect to bringing geology into the equation and thinking of time in terms of space. I think we're out of time, speaking of time.
Yes, but yeah, that's pretty much the gist of it. So yeah, Mike's going to put up the slide with some of our contact info if you want to reach out to Arcurve to learn more about some of the cool stuff that we do. And then, of course, there's some of the social bits. Yeah, I think we'll be happy to answer questions, again, either through the LinkedIn and the socials or in the various chats and things through Hopin. So yeah, thanks for your time, everyone, and looking forward to answering some of the questions. I see some of them in the chat already, so I'll try to address some of those as soon as I can.